This is second episode of trying to replace tokenizer with raw byte input for large language models. Episode 2, we are going to win against OpenAI and XAI and Anthropic in replacing tokens with raw bytes in large language models. Digital world is made of bytes, so it doesn't make sense to convert them to tokens or something else. Just currently tokens are most optimal, but the future is in bytes, and these companies are trying to do that, and open source should be open and science should be open and at the frontier and available to everybody. And there is no reason we cannot do it faster. There is more of us, so we want to do it faster before them. This is the first episode, link below, where I set up the research. I have my own large language model. This is the code for my large language model, and I'm just gonna now replace tokens with raw bytes and do research. You can follow these tutorials and learn even if you're a beginner, and you can contribute to open source and you can understand this, and this will make you top researcher if you want to understand this. So the idea is we have bytes and we want to group bytes into patches. So we want to process a few bytes at once. We want to put that into the transformer, into the language model instead of token. So instead of having fixed tokens in the beginning for all the whole training, everything, we want to just have bytes and then manually group bytes into batches. So if bytes are simple to predict, some simple words, then we will group more bytes. But if bytes are complex to predict, some difficult things to predict, some math problems, then we will group less and fewer bytes and process them. So this batch of bytes is going to be processed like a token. It's going to be converted into a vector embedding in large language model, and it's going to be processed like a token. So there is this big transformer language model, but there is a smaller language model, smaller transformer before that. This smaller transformer is just to figure out how difficult the bytes are currently, for these bytes are to predict, the current bytes. So that will also try to predict the next byte. And then if it's easy, if it's certain, if the probabilities are not uniform, if the probabilities are pretty certain for the next byte, then we will have some math formula that will give us low perplexity, low entropy. But if it's trying to predict next byte and all of the probabilities of the 556 and plus 2 more 558 possible next bytes, all are kinda equally possible, then model is confused, doesn't know what to predict, so the next byte is difficult to predict, so our math formula will give us high entropy there. So we will cut these bytes there, and then the previous bytes will be processed as a vector embedding, and then where it's difficult, we now process the following few bytes as separate vector embedding in the big transformer. So this small transformer is just to learn a little bit prediction, just so we know which ones are difficult to predict, which ones are certain and easy, which ones are unclear and difficult. I got this idea from byte latent transformer research paper by Meta. So the first research questions here is we want to find this threshold for entropy. So if entropy is high, it means next byte is difficult to predict, model is uncertain. Probabilities are all kind of equal. So higher entropy means more uncertainty. So at which one is the model performing best? So here, lower entropy, there will be more splits, more patches. Here, 3 high entropy threshold, so rare splits, large patches. Only like very difficult tokens will get split. So if we have entropy for this current byte to be over 3, then that byte is the first byte of the new patch. And if the next byte also has over 3, then that byte will be first token in its own batch. So then this batch will just have one token. So we always split at whichever byte threshold for entropy is above 3 in this case, or these other cases. So I want to experiment which threshold will give best performance. I'm going to measure training loss, validation loss, gradient norms. I'm not sure what this should show. I think it should show small gradient norms, so the gradients are not exploding. Learning rate, I'm not sure what we're measuring here. So these are suggestions by Claude Opus. I find this model best. So these are suggestions. I like these too. And we will also check these peak memory and steps per second. Because if there is fewer batches, we expect the model to train faster. Because more batches, more bytes get compressed into a single patch. So the research questions, suggested research questions are: what is the optimal granularity? How does patch size affect learning speed? What patterns does each threshold capture? Interesting. We're gonna see maybe these patterns. We can also check compression rate ratio on bytes. So I gave these suggestions to Claude 4 and it implemented these four models. You can find code in the description below, GitHub. So it's gonna do all of this good stuff here. We will get some data and images. I'm gonna use Novita AI. They have the cheapest GPUs that I know of. So if I go here, create a GPU instance, and I select a billing method, a spot, the thing here is they can take this when they need it. That's why they're 50% cheaper, but you're gonna have 1 hour notice before, and they don't need this. So and we don't need like so much compute. So I'm gonna take this one, 18 cents per hour. I think this is the cheapest one, and you can use this template. And next, and I think this is cheaper than Vast AI and other providers. You can support me by using my affiliate link. They will give me 10%, so you pay the same, they give me their money. But even if you don't use my affiliate link, this is the cheapest on the market. So I'll go here to connect, and you need to figure out this key if you don't have it, but I have it, so I'll just copy this command. So I'll take this GitHub repository of this project, and I'll git clone. And then I will cd into it. And then I'll Python and run LLM BLT ablations. That's the current file. So let's see what this is gonna do. I think we're gonna have to install. So pip install datasets, transformers, seaborn, matplotlib. I think that's it. You can create environment if you want, but I'm just gonna destroy this instance later. I got this error, so I'll just paste it back into Kiro. So it's gonna fix it, Sonnet. Now I'm thinking, how am I gonna keep track of my research? I think I'll just make a txt, like a markdown file, and just write it manually. The way this works is I'm coding on my local because I have some issues connecting like Kiro environment to this remote. So I just push to GitHub, and then I pull here, and then I try to run it here. And then again, I must say, now I see why they do research for like 5 months. This is a bit overwhelming and difficult, even though I have AI with me right now. But when AI generates code, there is a bunch of changes, and I need to go like line by line, figure it out. So we need to do that first, I guess, as soon as AI generates code. This is gonna train for 1.5 hours for some reason. Why 3000 steps train this long? I'm not sure. But AI can help me understand code, so it's good. I think the problem is this transforming patches into encoding them into the embeddings for the model. So I'm gonna interrupt it, it's too much. So I'm just gonna reduce the training steps to 300. I also wanna generate some text in the beginning before the training, after 100, 200, and after 300 steps. So I can see in the console if it's learning to generate better text. But now I see why it takes months. But hopefully with AI, we can do it a lot faster, because it's so good that I can talk to AI, ask it like questions, and I don't need to search for 10-15 minutes. So I push these changes to GitHub. I git pull here, This is interesting. Something is happening, but I don't know what. It's downloading the data and then initializing 4 byte latent transformer models. And then GPU utilization is pretty low. So I'm thinking I need to understand the code I'm running first. Mistake I've made. I should have tested just a simple small model with this whole architecture without trying to run different ablations. So I'm gonna try to do that first because it looks like this ain't working. So now we have this just 400 line file instead of 1200, so 3 times smaller. And I think this is the same. I need to see what Claude coded here. So this small architecture still has raw bytes as input, process them into patches, patch embeddings, and then latent transformer, and then decoder. Okay, this is fun. This is interesting because I can get deep understanding of this. But I have some videos, code AI research paper in 2 hours, where I let AI do research, but I guess that's not so good. So these real research papers that are gonna actually advance the field. Now I see why they take so long, but it is fun, it is interesting to understand all of this. We just need to figure out a faster way, utilizing AI to understand to code, and somehow to understand what AI is coding. We need to do it quickly. So right now I have whole LLM, everything in one file. So I guess I need to make it multiple files. I'm just figuring out how I can keep track of all of this, like having multiple files, different names. But then AI can change different files. I'm not sure. But the only reason I had it in one file is I can easily copy paste entire thing, share to people, share on my LinkedIn or whatever. Okay, it looks like we have to simplify this and understand the code because it just cannot fix it for some reason. Okay, now I understand it. So we need to train separate byte-level transformer language model that's going to predict the next byte. So this should be separate from our main thing. And then we will just calculate entropy based on that, the confusion. And then we will use that to divide whole thing into patches like we divide this into tokens. And then we will just treat those patches as tokens and that's it. But I want maybe to make a bit different architecture where the main model can decide which bytes to combine into patches, and as it's learning, it's gonna be able to combine more bytes. So it's gonna compress data and become smarter as it's learning. So can we do it based on its own entropy? So I think that's a really cool idea. Starting with training with bytes and then letting the model somehow combine bytes, merge them into vector embeddings. And the training here will be quite fast because it's just bytes. And this is the beginning generation. Why did model properly generate artificial intelligence here? This is so weird. It should be random. So why did it work so well here? I'm not sure. Now Claude says that the prompt was the future of artificial intelligence is, so the model is echoing back, repeating the artificial intelligence here and then generating random. But I'm still not sure how it's able to repeat. Shouldn't this be completely random model? So maybe there was some bug. I can't really be bothered right now. If this happens again, we'll try to find it. Maybe it was just bug in code and Claude said that it fixed it. Now after the 5,000 steps, which is just a few minutes, I see some coherent words being arranged from the balance of the head film. So it trained quite well. I think my large language model architecture is quite good because I'm using muon optimizer. It's like 2 times better, more efficient in learning, learns 2 times more from same data. And then I'm using rope. That's also good improvement in training and all of the latest things. So I think that's why it's so good. We have 2 options from here. First option, the way Meta did it, is to use this model to divide data into patches based on next byte entropy. The other option is to somehow use this model, do the same thing, but then train this same model as opposed to training different model on those patches. And then as this model is training, it's gonna learn to predict patches better and then learn to compress patches even more. It's like self-improving a little bit there. Now I'm not sure which one to choose because I heard like you need to replicate, put a lot of effort into replicating previous research and then building on top of that. If I start to diverge right now, maybe there will be like some very unexpected problems and it will not work. But I'm too curious, so I'm just gonna try to make this one model self-improving. So I'm asking Claude, I gave it byte latent transformer paper, just copy pasted with Control A, Control C, and I gave it my code. And then I said I have a different idea. I will train a byte level LLM for a bit, then use it to patch with entropy, then train on those patches. So I guess then there is no tokenizer anymore, because when I start training with patches, there is no tokenizer of the bytes anymore. Can this even work? My idea is LLM trains, improves itself, then entropy will get lower for patches and bytes. So I guess when I measure that entropy, I need to have tokenizer when I'm measuring the entropy. So maybe I want to have this middle part and then swap these two input parts. So one is bytes, raw bytes, the other is patches, embedding. So byte embeddings and patch embeddings, they are same size, just different things. And then I can also merge patches if there is low entropy between them later. So let's send this to Opus, the best AI right now, I swear. And let's see what it sees, what it does. This constant flattery is nice, but I must not believe this. But it's writing code. I want its thoughts, not code. I need to send a message again and say, write your thoughts, not code. Stability problem. We are constantly changing patches, and so we are changing the target. So maybe we can pre-train the model a lot and then change patches when it learns. But maybe there are some issues with condensing more and more bytes into patches, because we have these words, there are a few bytes, they're not like too many bytes. So maybe it's not even gonna be better if we just keep condensing more and more bytes into patches. And I don't know how to do it, how to replace it, because this one is using a cross entropy and the other is using cross attention and self attention. So I'm not sure how to combine it. So right now I think I'll just re-implement the byte latent transformer by Meta. And after I implement this, then I can figure out new ideas, because I still don't understand 100% this Meta's model. So I'll just re-implement it. By the way, we can convert pre-trained model like Qwen3 into byte-level model with this. That's just a cool idea. Maybe I should write it somewhere. So definitely Opus and Sonnet are not able to re-implement this, even if I give them LLM code that they just need to change. So I need to just go step by step from the beginning. So for example, here I see that their model in the paper is too big for one GPU. So I'm gonna also instruct. So this is Opus, I gave it paper, I gave it my LLM code, and I told it just to implement the first byte level entropy model that just calculates like next byte and then entropy. So I needed to add a few things. I first told it to use my own hyperparameters and model size in this template, because hyperparameters from the paper are too big. Model is too big. Then I told it to change code minimally, because Sonnet tends to change a bunch of code, do a bunch of stuff. So you need to tell it to change code minimally. And then I also wanted to save the model, because it doesn't save the model. And then I wanted to show some entropy calculation examples in the console after training, like for some bytes. So then, let's see, I'm gonna let it do it. So you need to be hands-on like this, read everything AI says, because even Opus cannot re-implement this completely. So you need to read like this. So now it's training again, and if I tell it to change something, write some code, if it starts changing more stuff, I will just stop it. I will not let it change this stuff. And my idea to make sure it implemented code correctly is to have these unit tests and printing like this at the end, so I know what the code does and if it works. And then I don't even need to understand what the paper was saying. The training worked well. Of this entropy LLM. So this is just a byte level LLM. I'm training this for who knows what time. Starts loss with 2 and then ends loss with 0.7, which is still a bit high loss. We could train it more, but this is just testing. It was very fast. And I'm using very good LLM architecture, which you can find here. So this is a sentence. I told Sonnet to also write these example sentences. This is important. And tell it not to change too much stuff, just minimum changes. Okay, so I'm checking the sentence and I see mean entropy 0.8, which is actually quite low. If you look at these entropies, all of them are so high. So how is mean 0.8? Minimum zero entropy. Maybe the formula is good, I think. Maybe entropy gets really low in the end. Different sentence, and we do see entropy going down later as we write letters. But mean is 0.3. It's very interesting. So I always need to constantly just supervise. So I'm asking Opus to explain what to do, and then I'm copying, but I need to ask it questions because it makes mistakes. So I'm telling it to do things, I'm supervising it, and then I copy this to Sonnet, and I tell Sonnet, I write all of these prompts. I say, don't make too many changes, you need to do these things, and then write prompts, write examples, print out things in the training so I see what's happening, so I can check everything is working well. It's done. So I'm running the code of the LLM now. It has encoder, middle LLM, big LLM, and decoder. So encoder is converting patches of bytes, just a group of bytes, into embedding of those bytes, and then there is a layer that converts embedding of the encoder to the embedding of the middle LLM. In the end, the final LLM prediction embedding gets converted into decoder embedding, and then decoder is converting embedding into list of bytes. So this will take 7 minutes to train, just 300 steps. It's taking more time right now. 300 steps would just be like half a minute usually, like in the tokenizer. So I'm not sure why it's so slow. I'm gonna try to ask. It's like 10 times slower because it has this encoder and decoder, but maybe it's processing one batch by one batch, not patch, batch. Is loss going down? But I have this. These prints are very useful, so I'm gonna copy all of this. Loss is maybe going down. My Opus 4.1 expired, or I used up, so I'm using Opus 4, thinking it's also good. I'm just gonna copy my LLM whole thing that was coded and these prints and ask it why is it so slow. So right now I'm quite happy because at least we have the working thing and we understand the architecture of this. So it says here training complete. Validation loss is kind of too big, but we just trained on 300 steps, which is way too low. But Opus recommended speed optimizations to remove my for loops and use GPU. I guess that's what Sonnet coded. Let me just do this now. We're gonna remove for loops. I tried doing some optimizations, but it looks like it's not even faster. I didn't read the code, there is too many changes. But I think I'll continue this tomorrow. Check the GitHub repository below and check my videos on my channel if you wanna learn this AI research and stuff. And see you next time.